In the diagram, two sides and a non-included angle of one triangle are congruent to two sides and the non-included angle of another triangle. So notice that even though two sides and the non-included angle of each triangle are congruent, the triangles are not congruent. From the diagram, you can conclude that side-side angle is not a valid method for proving two triangles congruent. This method, however, works in the special case of right triangles, where the right angles are the non-included angles. In a right triangle, the side opposite the right angle is called the hypotenuse. It is the longest side in the triangle. The other two sides are called legs. And the hypotenuse leg, or HL theorem. Theorem 4.6. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So if triangle PQR and triangle XYZ are right triangles, and segment PR is congruent to segment XZ, and segment PQ is congruent to segment XY, then the triangles are congruent. The hypotenuse leg theorem. Some conditions that must be met for the hypotenuse leg theorem. To use the hypotenuse leg theorem, the triangles must meet three conditions. First, there are two right triangles. Second, the triangles have congruent hypotenuses. And third, there's one pair of congruent legs. Problem 1. Using the hypotenuse leg theorem. Proof. On the basketball backboard brackets shown below, angle ADC and angle BDC are right angles, and segment AC is congruent to segment BC. Are triangles ADC and BDC congruent? Explain. Well, we're given that angle ADC and angle BDC are right angles. So triangle ADC and triangle BDC are right triangles. Condition 1's been met. The hypotenuses of the two right triangles are segment AC and segment BC, and we're told that segment AC is congruent to segment BC. So condition 2 has been met. Segment DC is a common leg of both triangle ADC and triangle BDC. So segment DC is congruent to segment DC by the reflexive property of congruence. And yes, triangle ADC is congruent to triangle BDC by the hypotenuse leg theorem. Your turn. We're given a diagram and this information and asked to prove that triangles PRS and RPQ are congruent. Followed by a reasoning item. Your friend says, suppose you have two right triangles with congruent hypotenuses and one pair of congruent legs. It does not matter which leg in the first triangle is congruent to which leg in the second triangle. The triangles will be congruent. Is your friend correct? Explain.